Okay, welcome back. And today we're going to start Chapter 3, Section 1. Chapter 3 is all about logic. And in the last video, we talked about in Chapter 1 on the different types of reasoning, branches of reasoning, inductive and deductive reasoning. And both of these require logic. So to be a reasonable thinker, um, to use reason, it relies on the rules of logic. And we're going to talk about the rules of logic because that is the tool we use to make sure that we are reasoning correctly. So in this section, we're going to talk about statements, negations, and quantified statements. And the objectives here that at the end of this video you should be able to do is identify English statements that are English sentences that are statements, express statements using symbols, form negation of a statement and what that is, express negations using symbols, translate a negation represented by symbols into English, express quantified statements, and what does that mean? We're going to talk about that in two ways, and then write negations of quantified statements. So a statement is a sentence that is either true or false, but it can't be both simultaneously in the same space and time. So a logical statement, is any sentence that is either true or false, but not both. So an example is London is the capital of England. That is either true or false. In fact, this one is true. Okay, but the main thing is it cannot be both true and false. William Shakespeare wrote the television series Modern Family. That is a logical statement because it is either true or false, but not both. In this case, this is a false statement. Okay. Commands, questions, and opinions are not statements because they are neither true nor false. Okay. They can be both in a matter of thinking. If you're in the same time and space, they could actually be both, depending on the group of people you're talking to. For example, Titanic is the greatest movie of all time. That's an opinion, right? Depends on who you ask. So if you ask a group of people, some people are going to say yes, some people are going to say no. Some people are going to say that's true, some people are going to say it's false. So that is not a logical statement. A command like read pages 23 through 57 is not a logical statement. If I start losing my memory, will I know? How will I know? That is a question. Questions have no truth value, right? So if something has no truth value, it cannot be a logical statement. So in symbolic logic, we use lowercase letters to help represent logical statements, sentences, if you will. So we could use P, Q, R, and S to represent. So this makes it very easy to represent and write down logical arguments, logical connections, and things like that, as you'll see. And instead of having to write out sentences all the time, we can replace those statements with letters, symbols, and write it using symbolic logic. So here's an example. We could say, hey, London is the capital of England, and we can represent that with P. So anytime I write down P, P represents the statement, London is the capital of England. I could use Q to represent William Shakespeare wrote the television series Modern Family. So if I write down Q, then Q represents this entire sentence. So the letter P represents the first statement, Q represents the second statement. Now, what is the negation of a statement? The negation of a statement means I'm taking the opposite truth value. So if I negate, right, means I'm taking the opposite of. If I want the negation of a true statement, that is going to be false. The negation of a false statement is true. So if I want to take the negation of Shakespeare wrote the television series Modern Family, I could do it one of two ways. I could write Shakespeare did not write the television series, right? So Shakespeare wrote, this is a false statement. The negation of that statement is going to give us this, which is a true statement. Shakespeare did not write the television series Modern Family. And that's it. That's simple. Another way to write it would be to say, hey, it is not true that Shakespeare wrote the television series Modern Family, or it is not the case that Shakespeare wrote the television series Modern Family. So in other words, I'm putting a not out in front here. That's basically what's going on. I'm putting a not. Okay, what about this? If I say today is not Monday, well, I could just basically say it's not true that today is Monday. So I'm basically putting a not out here, or it is not the case that today is Monday. Or I could just say today is Monday, right? So there's different ways of negating or writing a negation of a sentence using English. If we let P and Q represent the following statement, so again, P represents this statement and Q represents this statement, we could easily express the negation of these statements by basically writing it using symbolic logic. Okay, so A says Shakespeare did not write the television series Modern Family. So this is the negation of P. So we can write tilde P. This is the symbol tilde. So we can write tilde P. Today is Monday. Well, that's the opposite of Q. So that's the negation of Q. So we say tilde Q or not Q. So not P, not Q. Now, quantifiers. Quantifiers are prescripts or things that we put at the beginning of the sentence, usually, that quantify a set of objects or the lack of a set of objects, if you will. So words like all, every, apply to everything in a group that we're interested in a category. Okay, some or there exists apply to some or at least one, or there exists at least one subject or element of a set that has a certain characteristic. Or we say none or no one has a particular characteristic. Okay, so statements that containing quantifiers are something like this: all poets are writers, which means that every poet, if you're a poet, then you are also a writer. Some people are bigots. This means that, hey, what it's saying is there is at least one, or there exists at least one person who is a bigot. Okay, so that's what it's saying. Some means at least one, or there exists one person, at least one person. No math books have pictures. This is saying that none, there is not one math book that has a picture. Okay. Some students do not work hard. That means that, hey, there has to be at least one student, right? The saying there exists one student that does not work hard. So here's a table that is a good reference table for you to start practicing or use to help understand how quantified statements work. Okay, so in symbolic we use sets. So we use capital letters for sets of objects. So we say all A's are B. So all A are B. In other words, another way of saying that is there are no A's that are not B's. There are no A's that are not B. So for example, we could say all poets are writers, or we could say there are no poets that are not writers. Those are saying the same things. They're equivalent. Some A are B. This means there exists at least one A that is a B. Or another way of saying it, or no, that's the only way of saying it, sorry. Some people are bigots, so there's that one. We could say at least one person is a bigot, like we said. No A are B. Another way of saying that no A are B is that all A are not B. So no common colds are fatal. That means that all common colds are not fatal. So again, these are two ways of saying the same thing. Some A are not B. Another way of saying is not all A are B. Okay? Or there exists at least one A that is not a B. So some students do not work hard. Or we could say not all students work hard. Saying the same thing. Now, To understand the negation of a quantified statement, we have to understand the difference between a universal quantifier and an existential quantifier. Existential meaning existence, right? So anything that has some or there exists at least one are existential quantifiers, meaning there exists, right? It's a question about existence, okay? So anything that has a sum is an existential quantifier. Anything that says all, none, every, no one, those are universal quantifiers, meaning universal applies to everything in the category, right, in the set. So if you notice the arrows, the opposites, the negations of universal quantifiers always lead to an existential quantifier. The negation of an existential quantifier always leads to a universal quantifier. So if I say all dogs are animals, and I want to negate that, then the negation would be that some dogs are not animals. All dogs are animals. Some dogs are not animals. In other words, what do I need to do to make this false? If I say all A are B, and I want to make that false, I just have to find one A that is not a B. That's this. So the negation of an all statement just means I have to find one that is not. Now, if I say no A's are B's, then the negation of that, to make that a false statement, remember, like a counterexample, all I have to do is find one A, right? No A's are B's. All I have to do is find one A that is a B. So there exists at least one A that is a B. Okay? So these are opposites of each other. So these are negations. So pay attention to this as a review. Now, with Venn diagrams, we can use Venn diagrams or Euler diagrams to write this as well. So in an Euler diagram, we have these circles, right, that represent sets of objects. And so in this case here, we're saying all poets are writers, which means if you're a writer, then if all writers are poets, then we would expect all writers, the set of all writers, to be inside the set of all poets. So that way, if you are a writer, then you must also be a poet. If I say some writers are not poets, then I'm going to have two overlapping circles where some of the writers are outside the circle of poets, which means some writers are not poets. Or in other words, I could have two overlapping circles, and I'm interested in the middle piece where there's a little bit overlap, which means some canaries weigh 50 pounds. So there exists at least one canary in here that weighs 50 pounds because there's an overlap. So we represent that with this overlap with the intersection. And then the negation of that would be no canary weighs 50 pounds, which we would represent that as two disjoint circles. So there's no overlap, which means that if you're a canary, there's no overlap because these are objects that weigh 50 pounds. There's no overlap. So no canary weighs 50 pounds would be represented by this diagram. So now, negating a quantified statement. So if I had a mechanic and the mechanic told me all piston rings were replaced, and then later I learned that that mechanic never tells the truth, what can I conclude? Well, that the statement he made is false, so that the true statement is the negation of that statement. So the truth would be the negation of what he told me, right? So we would say that what? Well, first thing we start with is the mechanic statement. All piston rings were replaced. But we know that this is not the truth, right? He never tells the truth. So the negation of what he told me is going to be the truth. And so how do I negate this? Well, it's a universal quantifier, right? Which means I'm going to have to change this to an existential quantifier, sum. So if all piston rings were replaced, then the negation of that would be what? I would have to have at least one piston ring that what? Was not replaced. So the negation of this would be at least one piston ring was not replaced. Okay, or it's not the case that all piston rings were replaced, right? So I can write it that way as well. Okay, so what can I say? The negation of all A or B is some A or not B. So in this case, I can conclude that what? Some piston rings were not replaced. Or in other words, at least one piston ring was not replaced. Either one of these is saying the same thing. Okay. Some in logic, some means at least one. Okay. Some in regular English means more than one. But in logic, some just means, hey, what I'm saying is that there's at least one. Okay, so that ends this section. So next time we'll continue on with logic in section 3.2. Until then, please take notes, practice these, go through some of the examples in the textbook, do some of the other examples in the textbook for practice and see if you can get the answers. Reach out to me if you have questions, but make sure you have all your questions. Take notes so that when we get to class, we can jump right in and I can answer your questions. We can start practicing this stuff. And the more we practice, the better you're going to be at this, and then you're going to ace the exam. So again, just be prepared to work in class. Until then, have a great day.